Today we're going to talk about the multiplication principle and permutations. So the multiplication principle refers to when we are looking at a situation where you have some n number of choices that have to be made, and you want to come up with how many different ways are there to make the entire sequence of choices. So for example, let's say you had some n number of choices that you had to make, and for the first choice you have M1 ways to make choice 1. You can fill it in with any number there. M2 ways to make choice 2, and so on, all the way up to N. So Mn ways to make choice N. Now, if you want to know altogether how many different combinations are there of coming up with a sequence of choices, then you would have to simply multiply all of those number of ways for choice 1 multiplied by the number of ways for choice 2, and so on. And that will give you all the ways which you can make a sequence of choices. Let's take a look at an example. A certain combination lock can be set to open to any 3-letter sequence. How many sequences are possible? Now you can see how this is going to get us into probability, because we want to know, well, how many different ways are there? So you're really coming up with the number typically that's on the bottom when you're talking about probabilities. So how many sequences are possible with this combination lock? Well, think of it this way. It's a 3-letter sequence. So I'm going to put in 3 blanks there. And then I'm going to write down how many possibilities there are for each. So in the first blank, how many ways are there of coming up with something that goes in that blank? Well, there are 26 letters in the alphabet, so there are 26 possible things that could be in that first blank. And then the second blank, well, that could also be any letter, so that is also going to be 26, and same with the last one. So you would simply multiply 26 times 26 times 26, and that will give you the number of possible combinations. So multiplying this out, we get 17,576. And so here you can see how we can use this, perhaps later on, when we talk about probabilities, to determine, well, what is the likelihood that your combination lock will be able to be opened if, say, you tried it like 10 times. If you tried 10 different things, well, it's still 10 out of 17,576 possible combinations. All right, part B, how many sequences are possible if no letter is repeated? So we'll do the same thing. We'll have 3 blanks here. Now we know that first slot can be filled in with 26 because we know, well, it could be any letter. But then once one letter has been taken, it says that no letter is repeated. That means in the second slot, there are only 25 options. We don't know which 25 letters are left, but we know there are 25. And then you go to the last slot there, and you know since the first 2 blanks have already been filled in with 2 letters, 2 different letters, then you know that there's only 24 letters remaining for you to choose from. So in that last one, we have 24. Now go ahead and multiply those, and we get that there are 15,600 possible combinations that can be set up if no letter is repeated. All right, look at example 2. A teacher has 5 different books that he wishes to arrange side by side. How many different arrangements are possible? Okay, so there are 5 different books, so I'm going to put 5 spaces there. Now, if we're trying to arrange these books, how many possibilities do we have in that first slot? Well, we have 5 different possibilities, so I'm going to write a 5 in there. Now, once that slot has been filled in, how many books are left for us to choose from to put in the second slot? Only 4 left. All right, so now I only have 3 books left. That goes into the next slot, and so on until you get to the last slot. So 5 times 4 times 3 times 2 times 1 is equal to 120. So there are actually 120 different ways that those 5 books can be arranged on that shelf. Now, another way to write this expression, 5 times 4 times 3 times 2 times 1, is like this. This is called 5 factorial. So we use an exclamation after the 5. This means that you continue to multiply the next integer value down until you get down to 1. So here's factorial notation. So n factorial, so n with the exclamation, is equal to n times n minus 1 times n minus 2, all the way until you get to 3 times 2 times 1. Now, the second thing to note is that, by definition, 0 factorial is going to equal 1. All right, take a look at example 3. Suppose the teacher in example 2 wishes to place only 3 of the 5 books on his desk. How many arrangements of 3 books are possible? All right, so we're only putting 3 books down. So I'm going to have 3 spaces here. Now I'm still choosing from the 5 books. So I'm going to start off with 5. And then after the 5 books, I only have 4 books left and 3 books. And then the other 2 are just simply not going to be arranged on the desk. So 5 times 4 times 3, that's equal to 60. So what this is what we call a permutation. So a permutation of R elements from a set of N elements. So in the example we just did, we were taking 3 books from a set of 5 books, is a specific ordering or arrangement without repetition of those elements, those R elements. So in the example before, we took 3 books out of the 5 and we ordered them in some specific way. We did not repeat any books, and we only arranged 3 books. Now, in terms of a formula, this is it. So this is on the left-hand side here, the notation. This is for permutation, so the P is for permutation. N is the total number that you're choosing from, and R is the actual number you want to take. So, for example, with our last example, we had 5 books altogether, but we only wanted to arrange 3 of them. So we would write 5P3. And then in order to simplify this, you would have n factorial in the numerator, and in the denominator you would have n minus r. You want to solve that first, and then the factorial of that. So just as practice of using this formula here, find the following: the number of permutations of the letters A, B, C, and D. Okay, so we have 4 letters to work with. We want to come up with permutations, so we're trying to come up with all the different ways we can order these 4 letters. So we're using all 4 of them. So this is going to be 4P4. Typically you would read this as 4 permute 4. And using the formula, we have 4 factorial up on top, and on the bottom we have 4 minus 4 factorial, and you can see where the 0 factorial now comes into play. So 0 factorial is equal to 1. So now we have just 4 factorial, which is 4 times 3 times 2 times 1, which is equal to 24. So there are 24 ways that we can rearrange those 4 letters A, B, C, and D. All right, part B, the number of permutations if just 2 of the letters A, B, C, and D are used. So now we have 4 elements, but we're only going to take 2 of them. But we are going to order them in some way, arrange them in some way. So this is going to be 4 permute 2. So putting that into the formula, we have 4 factorial up on top, 4 minus 2 factorial on the bottom. So now I have 4 factorial divided by 2 factorial. So that's equal to 4 times 3 times 2 times 1 over 2 times 1. You'll notice here, if you want to, you can absolutely cancel out the 2 times 1 that's in the numerator and the denominator, leaving you with 4 times 3. Or you can simply multiply the whole thing out and divide by 2. So 24 divided by 2, which is equal to 12. All right, now the next thing we're going to talk about are what we call distinguishable permutations. So distinguishable permutations has to do with the situation where you may be ordering certain things, but there are objects that are not distinguishable. So when you're coming up with distinguishable permutations, you're coming up with, well, this one is not distinct from this one. So how many distinguishable permutations are there? So if the n objects in a permutation are not all distinguishable, so if there are n1 of type 1, n2 of type 2, and so on, for r different types, then the number of distinguishable permutations is given by this formula. So essentially what you have is the total number up on top, factorial, And then you're going to divide out whichever ones you have repeats of, whichever ones are not distinguishable. So you're dividing out indistinguishable elements. All right, so take a look at example 5. In how many ways can the letters in the word Mississippi be arranged? All right, so Mississippi, first, let's count out how many letters there are altogether. So if you count out the letters in Mississippi, it looks like there are 11. So on top, we're going to have 11 factorial. Now on the bottom, we want to divide out anything that's indistinguishable. So in other words, anything that repeats. So imagine taking the letters in Mississippi, and if you were to take the third and the fourth letters, and you were to swap them, we would say that swapping those two letters makes those two arrangements indistinguishable from each other. So what we're trying to do is we're trying to divide out those indistinguishable permutations, and that way we can come up with how many distinguishable permutations are. All right, so if I were to swap the M and the I, then obviously it's going to be very distinguishable. But if I were to swap any of the letters that are repeated, so the P and the P, if I swap those, then it's going to look exactly the same. So let's count out how many repeats we have. So it looks like we have 4 I's, 4 S's, and 2 P's. So I'm going to divide those all out. So on top we have 11 factorial. On the bottom we have 4 factorial, and 2 factorial for the 4 I's, the 4 S's, and the 2 P's. All right, and then simplifying that, we end up with 34,650. All right, we have one last problem. A student buys 3 cherry yogurts, 2 raspberry yogurts, and 2 blueberry yogurts. She puts them in her dormitory refrigerator to eat 1 a day for the next week. Assuming yogurts of the same flavor are indistinguishable, in how many ways can she select yogurts to eat for the next week? All right, so first start off with how many yogurts there are altogether. So 3, 2, and 2, so that's 7 altogether. Now on the bottom, we're going to write out everything that is indistinguishable. So we're told that yogurts of the same flavor are indistinguishable. So we have 3 of the cherry, 2 of the raspberry, and 2 of the blueberry. So we're going to have 3 factorial, 2 factorial, and 2 factorial on the bottom. Simplifying this, we get that this is equal to 210. So there are 210 ways that she can select yogurts to eat for the next week. All right, so today we talked about the multiplication principle, how you multiply all the different ways that you can make specific choices. We talked about permutations. So if order matters and you're not taking all of the objects at once, you can use permutations in order to determine how many possible ways of arranging R elements out of N elements. And then we talked about distinguishable permutations. So in the cases where there are things that are what we call indistinguishable, or you can think of them as repeats, we simply divide those out in the denominator.